This is your second semester in transition AMP Up. I just do want to remind you real quick, rounding will be indicated on each one of your problems. And also do not ever round any weight if that is something that comes up in your problem. Okay, so first of all, know your units. Okay, so if you still haven't got your units quite down, make sure you know those before you go in to take your test, because any and all units can pop up. Number 2, calculating the intake from your patient's lunch in milliliters. I think that should say they consume 300 milliliters of water, 8 ounces of apple juice, and 2 cups of broth. Okay, well, let's add those up. So they consumed 300 milliliters of water. They had 8 ounces of apple juice. So we're going to have to start off by converting the 8 ounces to milliliters. 1 ounce is 30 milliliters. So when I convert 8 ounces to milliliters, we're going to have to multiply by 30. 8 times 30 is 240 milliliters. And finally, 2 cups of broth. The 2 cups, again, have to be converted to milliliters. 1 cup is 240 milliliters, so 2 cups, we'd have to multiply by the 240 to get 480 milliliters. You'll grab your calculator, and again, this is a great time to remind you to verify what you have entered into the calculator before you hit equals. That way you don't get the wrong answer because you didn't press it hard enough or you pressed it too hard. When we add those 3 values up, we do get 1,020 milliliters. For number 3, the order is 200 milligrams, so that's our dose, by mouth, BID, twice a day. How many milliliters will you administer per dose? This drug comes in a vial labeled 125 milligrams per 5 milliliters. Okay, always underline what you're looking for or write it down for yourself. So we're going to start. Because they gave you a vial or a label or a box or an ampule, whatever it is to read, this is going to be a dosage problem. So you're going to write that in a ratio, 125 milligrams per 5 milliliters. Copy your units over and then put the order in. The order, or 1 dose, was 200 milligrams. So that means we're looking for milliliters. We're going to multiply down the 2 diagonals and set them equal to each other. So we're going to get 125x equals 1,000. After dividing both sides by 125, our x will be equal to 8. And don't forget, just like in our practice, there's the units. Make sure that you build your ratios with the units on them so that you'll never miss a problem because you indicated the wrong unit. And again, rounding will be indicated. Number 4, we have 20 milligram tablets on hand. The order is for 0.04 grams by mouth daily. How many tablets will you administer? Anytime that you have a tablet problem, the formula is give over got. What do we want to give? What was the order? The order is for 0.04 grams daily. So what have you got on hand? What do you have? We have these 20 milligram tablets. The big deal with tablets, guys, and make yourself a note, is to match the units. So I'm going to start off by converting my grams to milligrams, and that's a great time to review our King Henry. King Henry died, and you pause. That's where grams, meters, or liters are, our base units. Drinking chocolate milk. 2 pauses because you're really broken up. Muck Monday. To get from grams to milligrams, it is 3 units to the right. So we're taking our decimal and moving it 3 places to the right. Here's where my new decimal place is, so we're going to put in a placeholder 0, but we will drop off the 2 trailing zeros. So my problem becomes 40 milligrams over 20 milligrams. So it is 2 of the 20 milligram tablets that we're looking for. In number 5, the order is for medication A, 350 milligrams in 225 milliliters to infuse over 1.5 hours. The drop factor is 10 drops per milliliter. How many drops per minute will the client receive? Don't forget what we talked about. When you're setting a pump, you're looking for milliliters per hour. When you're looking for an infusion rate, we are looking for drops per minute. So this is an infusion rate. So let me remind you about the formula. The infusion rate formula says you take the milliliters to infuse, you multiply by the standard drop factor, and then you divide by the time in minutes. So here we are going to infuse 225 milliliters. We're going to multiply by the standard drop factor, which is 10, and we will divide by the time in minutes. Because this is being infused over 1.5 hours, that is 90 minutes. We'll put that into our calculator. Let me grab mine. The way you put it into your calculator is 225 times 10 divided by 90. And it comes out to 25. And remember, because we were looking for the infusion rate, that is in drops per minute. So remember, drops can be abbreviated as GTT, GTTS, or drop. Any one of those is acceptable. Number 6, medication A, 225 milligrams in 325 milliliters to infuse in 45 minutes. What rate will you set the pump in milliliters per hour? Remember, setting the pump is milliliters per hour. So this is one where you just have to match up the time. We know that we're going to get 325 milliliters in 45 minutes. Copy the units over, but this time we know that our minutes have to be 60 because we're looking for the milliliters per hour. So we did lots of these on our review. If you need more practice, go back over that. We're going to cross multiply, set them equal to each other. So we're going to end up with 45x equals, and then 325 times 60 is 19,500. I'm going to divide both sides by 45, and so we're going to end up with x is equal to, and I'm going to have to put that in my calculator. Don't know that one off the top of my head. Okay, this one gets us a repeating decimal, which is wonderful so that we can actually talk about rounding. Now, because this one is setting a pump, milliliters, typically when you're setting a pump, the milliliters will be whole numbers, but let's not assume that. They could ask you to round to tenths or hundredths or whatever decimal they want you to. It will be indicated on each problem. I'm going to go ahead and round this one to whole units, so it's going to be 433, and again, because you built the units into the problem, it is milliliters per hour. You will have a place to put the number value, and you'll also have a place to put your unit. Let's look at number 7. A patient weighs 110 pounds and is to receive a drug at a dosage of 5 milligrams per kilogram of body weight. How many milligrams will you administer? Well, if they weigh 110 pounds, but my dosage is per kilogram, I'm going to start off by converting the weight in pounds to kilograms. That is done by dividing by 2.2. So that's going to give me 50 kilograms. Now, multiply their weight in kilograms times the dosage. It is 5 milligrams per kilogram. Notice when you do that product, the kilograms are going to cancel, And 50 times 5 is 250. And the unit, if you set it up with the units every time, will be built in. That is milligrams. And last one, we're going to manage to get it all in the first video. Don't forget there is one more video for the transition math also, which we're all responsible for. Just in case we need osmolality, I went ahead and included the formula. Last semester they asked me to put this on there, so I'm going to do it with you guys again, or so that you'll have it. There's a Bunn count of 9, a sodium count of 160, and glucose, or sugar I guess, is 216. I'm going to plug in. Now I'm thinking, is that potassium or sodium? I think that's potassium. I don't know. 2 times 160. Let's see, the glucose is 216 divided by 18 plus the Bunn count divided by 3. I'm going to write underneath here how you would type that into your calculator. 2 times 160 plus 216 divided by 18 plus 9 divided by 3, and then hit equals. And on this one, we're going to end up with a 335. And I'm not real sure about the unit on that. That's not something they've ever given me. All right, I'll see you in the next video.